Hey, what's up, people here? Today I'll be showing a quick example and a tool that can demonstrate that ingesting events in Stellar doesn't have to be complicated. So this is the common friction point or challenge for new developers coming into the blockchain space. You gotta at a certain point interact with events. And this is a way developers use to provide external applications with information and with insight about what is going on within the transactions. So let me just switch it real quick here and let me go over expert. So here I'll just get XLM and show for those that are unaware, this is the XLM contract, these are the transactions for the past few hours. Now select a random one, and if we just expand over here, there's a bunch of things going on in this transaction, but we can see this section over here, which says that the contract, and here's the address of the XLM contract, it's saying that it raised an event for a transfer. So this is the first topic, and the first topic is indicating what kind of action happened. Then it says that this address sent some amount for this other address, and then the assets involved, in this case the native XLM, and then the amount sent. And the reason why interacting with this can be hard sometimes is that this whole format is very flexible and can be customized for each different use case. So if you don't know what you're handling, if you don't know what standards you're interacting with, you can get into a pretty difficult situation to get the right events or to identify if those are relevant to what you're looking for. So for this demo today, I'll be using the Colibri SDK. This is a TypeScript toolkit that I've been working for the past few months. It's in beta, but it's fully open source and has already a bunch of specific packages for different use cases. And in this one, I'll be using specifically a tool called EventStreamer. So I'll come here in the documentation. The EventStreamer is a tool that provides with a class for interacting with the RPC instance, and it has three different modes that it can run. It can run on live mode, archive mode, and the auto mode. So just to give you some context, by default, these RPC instances, they operate with a retention window of about 7 days. And if you're trying to use the get event function within these 7 days of data, you won't have a lot of trouble. It will be very simple. You find the data and you'll be able to ingest it. But if you're working with older events that are beyond this retention window, now you need a specific different type of RPC instances, or you need to connect to different data source. So there is what we call archive RPCs, which are RPCs that are connected to a data lake that has historical ledger entries for the past, older transactions and older blocks from the network. So what we're doing in these different modes is that when we're engaging with live mode, we are operating within this retention window. When we're engaging with the archive mode, we're going beyond this retention window and we're ingesting raw ledger blocks and extracting the events that we're looking for. But the tool handles the hard work for you, and it provides you with a standardized experience across these two. And the auto mode basically will look for the parameters that you're providing and automatically identify if you're trying to do a live ingestion or an archive ingestion and switch as necessary. So let's go ahead and start our examples. Oh, and before I forget, all those links will be shared in the video's description. So the repository, the documentation, as well as there's another repo with the EventStreamer example, which has the full code snippet that you can play with yourself and you can customize and try in different ways. So for this, we have this blank project, which I just started. It has nothing so far. I just configured a Dino.json with the Colibri core and the Colibri Event Streamer packages. The core contains a bunch of reusable building blocks that are relevant for most use cases, and the Event Streamer is specific with this tool. So let me go here. We have the ingest.ts file, which is our entry point, and it has just a console log. So if I come here and run dino task ingest, our task, it's just console logging, it's not doing anything. So let's start by instantiating a new event streamer and just looking at some of the events that are happening right now in the network. So I'll start by importing the event streamer from Colibri Event Streamer. And in order to instantiate it, I'll also need something else. I'll need to indicate what is the RPC I'm connecting to. So let me just start and instantiate the streamer. Let's call it live or just event streamer. It's a new event streamer. Oops. It's a new event streamer, and I need to provide the RPC URL. So in this case, I'll be using a public infrastructure from one of the ecosystem providers called Lightsail, and that's specifically because they also have an archive RPC that is free to use with mainnet data. So if you don't know these, you can import those predefined configuration from Colibri. Let me just add here Colibri core. We have these network providers, and these are basically public infrastructures that we know are available for everyone, and here they're connected to our CI. So as we push in new versions of Colibri, we always test to see if this infrastructure is up, running, and healthy before we approve the package to be published. So you can rest assured that these should be up and running. So for the Lightsail one, I want to get the RPC URL and the archive RPC URL. And I can get those from the network providers, Lightsail, mainnet. There you go. So that's what I'll be using here. So I'll be using the RPC URL for now in my event streamer. And what do I need to provide to the event streamer so we can start? So I can come here, call event streamer, start, and we can see that it expects an event handler and a bunch of options. And the options are optional, so we don't need this right now. We just need to provide a handler. So every time we find an event that matches our criteria, it's going to be passed to the handler. So const on event will be our function. And we have this exported type event handler to guide us here with the correct types. So, oh, thanks Copilot. So there you go. So we have this async function that is going to receive an event and log some information. So here, the event object will come in this specific class that we have, which extends upon the normal RPC data for events to bring additional capabilities. And we also use these to extend into custom event classes for standardized events. So for the SAC events, SEP41, and as other ecosystem standards rise, we'll be providing those. And you can as well use these classes to extend for your own event schema and your own events validation. So this should take out a huge lift and effort from interacting with these events. So right now, all I want to log for each one of the events that we find is just the ledger. So let me just come here and say event.ledger. I want to see what is the number, what is the sequence of the ledger in which this event was found. I want to log the event ID. So every event has a unique ID that is based on the transaction, the operation, and position within the block. And for which contract? So for contract event, that's not how it is contract ID. There you go, ID in the singular. So we'll just provide our own event here, and this should be enough to run. So let me go ahead and start ingestion. So what should we see right now? There we go, we're already finding a bunch of events. So here we're ingesting events for this block. Here are the unique IDs for each one of these events and the contract. These ones are all for the XLM contract. I believe this is how they ordered in the block. So there you go, now we have a bunch of different ones being issued as well. So we're just getting a bunch of random events. Since I use the start function, I'm using auto mode. So if I just say start and provide a bunch of data, it will automatically infer if I'm using historical or live. But if I want to be explicit, I can use start live or start archive. And this means that if I'm trying to ingest something outside of the retention window for the live ingestion, for example, it's going to fail because I'm trying to explicitly do something that is not possible. So I'll keep the auto mode for now, but we are doing the live ingestion. So let's start filtering and finding specific events, because we want to just look for a specific use case. So here, let's look for events involving the XLM contract. So for these, the EventStreamer also accepts an array of filters. And these filters, they are standardized in the RPC, the way the RPC receives these filters, but it's oftentimes a friction point for developers to understand how to better filter and find the specific format and shape for the events they're looking for. So here we have this helper called event filter. So you can instantiate a new event filter. So here I'll just use a filter XLM, and this is a new event filter, and we'll just filter by contracts. And the only contract we need to filter here is the XLM contract. And we'll provide these in our event streamer. So I can just come here and copy the contract ID of the XLM, but in this case, I'll do something different. We also have this client for Stellar Asset Contracts. So I'll use this client, Stellar, where is it? It's Stellar Asset Contract. I have a native XLM specific one, and I can just provide my my network configuration. So I'll use the light sail one, and I'll get the contract ID. So, oh, this is looking ugly. So let me just go ahead and start these in a network config. There we go, much easier, network config. And then I'm providing my network config and getting the contract ID. There you go, much better. So now my filter is looking for contract IDs. So this means that I'm filtering just for transactions that are using the XLM contract. But what if I want to look for specific types of events? So something that we can provide here are the topics, and these have a specific shape. So we can have a bunch of different topics, and we can provide those, like for example, with wildcards to say that we are trying to match any topic 1 or any topic 2, any shape or any number of different topics. We can use those. But here to facilitate, if we already know that we're looking for standardized events, we can add, for example, we are trying to add an SAC event of a transfer. So the transfer event, we can come here and say to topic filter, and let me just take these out. Perfect. So we have these helpers, which are standardized events for the ecosystem standards. So we have SAC events, we also have Step 41 events, and these have these unique classes for each one that parses these events, verify the right shapes, verify the right data, and know how to convert those into a more digestible way. And these are all based on specific event schemas like these, which means that you can extend these and create your own event schemas and your own event classes that facilitate your use case. So in here, I'll just use the transfer event to topic filter, which means that it's going to filter by transfer events. And this one is with the XLM asset. Hey guys, feel free to feature here with a small comment as I'm editing the video. Something I failed to tell you is that the two-topic filter for each one of these standardized events also helps you assemble these filters and with the other topics without having to use the wildcards and know the specific shapes. You can simply add additional filters that you want to narrow down in the events, like the from or the to field. So for example, in the transfer, if I only want transfers that are from a specific address, I can say to topic filter from address ABC. And if I want a specific event with a to as well, with a specific receiver, I can say to XYZ. And this will automatically assemble the topic filter to find this narrowed down version. So that was it. Let's get back into the video. So if I come here and toggle this on again, we should start finding, oh, I gotta save first. We should start finding less events than before, but we are still finding a number of those. So let's log more information. Now that we know that we're only looking for transfer events, we can convert these raw event that we're getting into a transfer event object. So it's easier for us to access its inner data. Sorry. So we'll go ahead and use SAC events, transfer event, from event. And we just pass on the raw event and it will be converted into a transfer event. So the transfer event, let's use these over here. Oops, here and here. So the transfer event has a bunch of additional functionalities, and it is already verifying the shape and the size and the data that is coming, so it's much easier to ingest these in your application. So I'll go ahead and console log. Let me just double check. Yeah, thanks Copilot. So we're already logging the from, to, and the amount, which are standard topics and data in these events. So we should see something more complete as we start ingesting. And there you go. Now we are only ingesting transfer events, and this is the shape. These are all the data for these transfer events. That's much, much nicer. Also, if we don't want to keep ingesting those eternally or just going on, we can set some boundaries. So we come here on our event streamer and we add some options, which are the start ledger. And I'll just add the ledger that we were looking in here, and stop ledger. We provide the same ledger. So this is an inclusive filter. So if I provide the same stop ledger as the start ledger, it means I'll just ingest this block and stop afterwards. So you can start, for example, and use these numbers to ingest the next 10 blocks, or if you just want to ingest the last 3 blocks or some specific period in which you wanted to observe, you can set these here, and the event streamer will automatically ingest just for that period. So it's going on, it's ingesting, and there you go. There wasn't a lot of transfer in these ones. That's nice. So what else can you do? You can also come here in the event streamer and you have a bunch of options that you can customize. Like, for example, the paging interval, the wait interval in between blocks. So these should be modified with some care, because you could be hitting like the API rate limits if you're using public infrastructure. So it's here as a convenience. If you're using your own and you want to ingest much quicker or use different setups, you're free to do that. So live ingestion, very simple. You can filter by the events you want. You can look for those. Let's switch it a little bit. Let's say we want to look beyond our retention window. So let's come here. I selected the transaction here, which is from early November, and it has some transactions involving the Kale asset. So let's switch the ingestion to use to go specifically for this block and try to find these Kale transactions. So let me come here and switch and modify the ledgers specifically for that block, and let me copy the contract ID of Kale. What is the contract ID of Kale? This one. So let me switch. Now our filter will become a Kale filter, and we are going to find events for Kale, and instead of transfer events, we are going to look for mint events, right? So let's switch the filter, event streamer. So if I just start it right now, and if I use live to explicitly use live, I believe this should be out of the retention window. So let me see. There we go. So we cannot start live. Live ingestion won't work because this block, even though it's a recent one, it's already beyond the retention window. So the oldest block we have is not as old as this one. So for this, I'll switch to start. Without the suffix, just start, and it will use the auto mode and switch to historical. So let me just double check here. One thing that we also need to change is that we were getting the events and converting as transfer events. If we do this right now, if we run this right now, it should fail. And the reason is because if we start using and filtering by mint events, we are not getting transfer events. So these should have a different shape. So we need to switch these to mint events, and mint events don't have a from field. They are slightly different. So what do the mint events? Let me just switch here and rename this to mint event. So what else do we have in the mint event? In the mint event, we have we have the amount, and that's pretty much it. We have some other information, but let's keep it like this for now. So if I go ahead and start the ingestion, oh, it's failing. Why is that? I forgot one thing. we didn't add our archive RPC to our event streamer. We only have the normal RPC. So I can come here and add the archive RPC. Now we should start seeing those. So it's starting the ingestion, and there you go. Now we can see that it went straight for that block and it started ingestion those KO transactions. And here we can see it was executed for the KO contract. Here are the receivers and the amounts and all of the events that were issued in that historical block. And you can see that the handler experience and the shape of the events, it's the same one as if you're using the live ingestion versus the archive ingestion. And that's something that we want to keep simple in these tools, so that if you're just trying to access historical data, you don't have to think too much, as long as you have the right infrastructure and you know what you're looking for. So this was a very quick example. We have these with much more details and well documented in that examples repository that I mentioned, and I'll be sharing these in the links. So I invite you all to get into this repo, have a look, try to run it yourself, switch the configuration, use it for your own events, try to break it, and share your feedback with us afterwards. So hope I see you next time, and I will be dying to hear about your feedback on these tools. Thanks so much. See you guys.